Welcome back, ladies and gentlemen, to the free response question review. Today we will be looking at the AP Calculus BC 2016 question number 3. This question was also shared on the Calculus AB exam as well. It reads, the figure above shows the graph of the piecewise linear function for f for -4 to 12, and the function g is defined that g of x is equal to that integral from 2 to x of f of t dt. So before we even answer any of the questions A through D, it's really important to note that in order to move from f to g, I have to do the integral to f so that f can become g. So by using some backwards logic here, then I could then assume that if I have to integrate f to become g, then I have to derive g to become f. Now, why is that important? It's because this graph of f really is not a graph of f at all. He's really a graph of g prime. And as long as I can know that relationship and establish that relationship during this problem, then I think a lot of these questions should be pretty easy to answer. So let's get started. Part A. In fact, the first few questions are a bunch of typing. Part A just says, does g have a relative min, max, or neither at x equals 10? And justify your answer. Well, at x equals 10, that's right here. And I know what you're thinking. It's totally a max because we're going from up to down. It looks maxy right there. But remember, the AP exam is designed by people who make these mistakes all the time, or they see these people making these mistakes all the time. This test knows what you know, and it knows where you're going to make your mistakes. So with A, what they're asking you is if there's a local max, min, or neither at x equals 10. The correct answer is that there is neither. So G has neither a max nor min at x equals 10 because g prime equals f does not change sign. Now remember, if there was going to be a max there, your slope values, which would be positive up top and negative on bottom, would be going from top to bottom. Likewise, if there was a min, they would be going from negative slope value, in other words bottom, to positive slope value, meaning top. Okay? So hopefully that makes sense. In part B, it says, does the graph of g have a point of inflection at x equals 4? Justify your answer. Well, remember, points of inflection are measured by a second derivative. So what I'm going to do is I'm going to look at g prime's slope. So, do we have a point of inflection at x equals 4? Well, a point of inflection would happen if g double prime, or f, changed signs, right? If g double prime changed signs, that means that f would have to be changing direction. So, I can say then yes, g has a point of inflection at x equals 4, because I can say g double prime equals f prime changes sign, or I could say f changes direction. So these questions here, when you have a graph that's the derivative of something else, they're usually pretty straightforward, I'm hoping. But yeah, let's move on to part C. And moving on to part C. So part C actually involves some computation. So we're going to skip the typing tool in this one. It says find the absolute min and absolute max on -4 to 12 and justify your answers. Okay, well let's just see what this looks like. Before I get started, actually, I misspoke. There's a little bit of typing in here. My candidates for absolute extrema are x equals, looks like -4, -2, 6, and 12. Now, why? Why is it these numbers? Well, remember, negative 4 and 12 are obvious. These are endpoints right here. But negative 2 and positive 6 are local extrema, with negative 2 being a local min and 6 being a local max. So from here, I just have to find out what the values are at all of these places. So what I'm going to do is I'm going to go ahead and just make a table. I like tables. And I'll go ahead and say x, and this is what the f of x value is going to be. Or rather, I apologize, not f, g. G of x, what the g value is going to be. So at x equals negative 4, x equals negative 2, x equals 6, and x equals 12. Well, remember the relationship. The relationship is g of x is the integral of something, right? So this would be then the integral from 2 to negative 4 of f of t dt. This would be the integral from 2 to negative 2 of f of t dt. This is the integral from 2 to 6 of f of t dt. And this is the integral from 2 to 12 of f of t dt. So how do we find these integral pieces here? Well, the integral pieces are really just the summations of the areas between the curve and the x-axis. So from negative 2 to 4, or rather from positive 2 to 4, so from 2 back to negative 4 is going to be all of this space back here. I'm going to get rid of that because I don't want to have too much red on the graph here. So from here, it looks like these two triangles, this triangle here and this triangle here, will cancel each other out, leaving me only with this right triangle right here. But because I'm moving backwards on this thing, it's important to note that anything that is above the x-axis is actually negative in value because I'm moving backwards. So what I'm going to do is I'm going to go ahead and draw this triangle here, and that has a width of 2 and a height of 4, meaning I've got 1/2 base times height, which is going to be 4. But I got to remember that he's negative because, again, I'm moving backwards. All right, let's try another one. From 2 back to negative 2. So again, from 2 back to negative 2, I'll go ahead and change colors real quick here into blue. From 2 back to negative 2 is just going to be backwards here all the way to here. So this triangle that I'm looking at right here. So that is going to be 1/2 base, which is going to be, looks like 4, times height, which is 4 again. So I'm going to get 8. But remember, it's negative again because I'm moving backwards on my integration interval. So make sure you keep that in mind. From 2 to 6, I think that should be relatively simple. From 2 to 6, I'll go and change colors to green here. From 2 to 6, hey, from here to here, it's the same elevation as this triangle, so I think this is just going to be 8. It's just going to be 8. Cool, we're making good progress here. And then from 2 to 12, looks like we're going to go, I'll go and change colors here to purple. This triangle here will cancel with this triangle here, giving you only a negative value. So it looks like 1/2 base, which is going to be 1/2 times 2, times negative 4 should be negative 4. So it looks like these are my winners. So from here, I will go and just finalize my answer and say G has an absolute min value of negative 8 at x equals negative 2, and G has an absolute max value of 8 at x equals 6. And there goes C for you. Let me go ahead and clean up the board a little bit. Actually, no, I don't think I need to clean up the board at all. I think for D, I think I can just kind of move him into that little black space on the right side. I think I'm okay. I'm going to have to change colors, though. This graph is getting kind of messy, but that's all right. We can deal with him. Okay, so for D, we're just going to go and find the intervals between negative 4 and 12 at which g of x is less than or equal to 0. So g of x being less than or equal to 0, that's like saying the integral from 2 to x of f of t dt being less than or equal to 0. In other words, I want my area to be less than or equal to 0. So, what intervals allow that to happen? Well, let's go ahead and change colors here. I'm going to change to my final color, this sky blue color. I think that's the only color I haven't used yet. So I'm starting at this 2, right? That's where my integral begins. So what I'm going to do is I'm going to start moving to the right. And I'm going to tell you what type of area I have accumulated. So if I move to the right, right here, I have now accumulated positive space. Because I'm moving to the right, my triangle is above the x-axis, I'm positive. So from 2 to 6, I'm totally positive. So that's not going to fulfill my area being less than or equal to 0. Well, what if I go from 2 to 8? Well, from 2 to 8, I get all this positive space. And then from 6 to 8 is some of this negative space. But that negative space is not strong enough to knock out this positive space of this massive triangle. So from 2 to 8, I'm still positive. So again, I have not met the requirement of the area being less than or equal to 0. Well, from 2 to 10, if I go from 2 to 10, now I think I'm getting somewhere, because this triangle here on bottom is enough to knock out this triangle here on top. So that leads me to believe that my first place of zero-ness is going to be 10. And if I extend out from 10 further, I will start to become negative, and that's why from 10 to 12 is one of the intervals under which my g of x, or my integral, will be less than or equal to 0. So from 10 to 12 is definitely one of them. Well, where's the other one? Well, I can move forward if I wanted to. I could move forward, but I could also move backward here. So from here, from 2 back to 0, this triangle is above the x-axis. Well, I'm thinking that's negative because we're moving backwards. I can continue my negativeness by continuing to move back to negative 2. So looks like from negative 2 to 2 is going to be a qualified interval under which this integral is below 0. But if I go all the way back to negative 4, some of this area here is below the x-axis, which then knocks out some of this area. But again, like we saw on the right side here, this negative triangle is not strong enough to knock out the whole negativeness of this triangle here. Remember, when we move backwards, our poles are reversed. So the positiveness of this under triangle is not strong enough to knock out the negativeness of this upper triangle. So that means that my entire interval from negative 4 to 2 is also what I'm looking for. So if I put it in the right order, will be from negative 4 to 2, and then 10 to 12. And I think that just about wraps it up. So here is this video here. As always, comments and questions in the comments area are welcome. I will see you guys in the next one.